Hello, Marauders, and welcome back. We are starting another chapter on geometry. This is chapter 8. And of course, we won't be able to do the entire chapter, but we'll do what we can over the next 4 days, and Friday we'll have a test. And I'm not sure why there's a stingray on me, but let's get him out of there. Okay. But look at this building behind me. Is it perfect? Is it symmetrical? Do you know what those angles measure? How could you figure it out? That's what this chapter is about, trying to solve for the angles. I'll give you some angles, and then using a bunch of knowledge, you can solve for all of them. Okay, so in this chapter, you're going to have some neat puzzles. I think they're a lot of fun. I'll tell you an angle, and with just that, can you solve for all of these? There's no using a protractor and measuring it, but these markings tell you some things like, see how these angles are marked? That means these two have the same measure. They're exactly the same. Or these two lines are the same length, but I'm not solving for lengths, I'm solving for angles. Remember these little double lines that are bent? That means these are parallel. So your goal is to be able to solve puzzles like this. So before we do that, let's get the basics down. So there's a lot of little basics, little clues, but when you put these together, you can solve really complicated things. And first, let me show you some of this geometry in real life. Okay, so like here's some construction. These are what they call trusses. If you looked inside like a garage up at the ceiling, you might have seen this network or lattice of wood. And there's different designs. It's not just randomly put there, but it's for strength. When you looked at something, do you know if this angle here is the same as this angle? I'm having trouble writing there. Is that angle the same as that angle? Well, they have to make it the same, otherwise you'd have a crooked house. How do they get it to be the same? And of course, if these angles were the same and I mark them, you might have said, hey, this must be an isosceles triangle. Then this piece would go with this piece, because these would be a tie. But what about this? Is this the same as this? Does this cut this in half? Let's hit the next one. And there's all types of stuff around us. Look at all the angles and stuff here, all these pieces. This guy's an inspector, and he's saying, is this thing put together correctly? He's seeing if everything's done right. All this stuff has to be done correctly. Look at all that. So the more complicated the job, the more mathematics you have to know. Here's some more. This is a hexagonal gazebo. This here is like a roof to a pentagonal gazebo. Here's some more. Here's some more. Let me get the marks up here. Here's a bridge. Notice all the triangles. Triangles are the key. Without triangles, it'll fall apart. But you can't just randomly make them, but it's all geometric. There's all these different designs. And of course, they got names for the parts. Look at that. If they don't do it right, they spend a lot of time, a lot of money, but they got to get all this stuff perfect. Here's some more bridges. Look at these kids up here. Looks fun. Here's one before, 3 days later, after. Whoops, someone didn't do their geometry right. Okay, I'm going to run through some basic ideas that you have to know to be able to solve these complicated things. The first thing, you already know it. If you have a triangle, the 3 triangle angles always add up to 180. They might not all be the same. They could be different. You know, if you had a crooked triangle like that, is it the same? Is it perfect? I'm not sure. You can't just assume these are the same. Maybe this could be 40, and this might be 50. And this could be X. Now, I might not have drawn it to scale, but then you could solve for that piece. Sometimes they might even put lots of letters in here. Let me make some type of other triangle here. I might say this is X, and this is 2X, and this is 3X. But I do know that these 3 angles, X plus 2X plus 3X, adds up to 180 degrees. And I could actually do some math here. Let's see. 1, 2, 3, 4, 5, 6. That's 6. 3, 2, and 1. 6x is 180. So divide by 6. X could be 30 degrees. Oh, X is 30. Then I could go back and I could plug this in and go, oh, you must be 30 degrees. And you're 2 times 30. So you must be 60 degrees. And you're 3 times 30. You must be 90 degrees. 30 plus 60 plus 90 does equal 180. Sometimes you might see a triangle like this. Right, the board's on some bumpy surface here. Sometimes you might see a triangle and they might say, hey, this side is the same as this side. If you go, hey, if these are the same, this one must be like a reflection, a mirror image. It must be the same left and right. If these are the same, then this angle over here and this angle over here must be the same. Remember the isosceles triangle. It's got 2 sides and 2 bases are the same. It's the opposite pieces. And then they might say, hey, this piece is 20 degrees. Could you solve for the others? And you're like, well, if these are the same, these are the same. So this would be 20 degrees. But then what's the leftover piece? Oh, wait, this piece plus 20 degrees plus 20 degrees is 180. So let's see, there's 40. So x plus 40 degrees is 180. And so I could subtract the 40. So x is 140, which sounds reasonable because this angle looks pretty big, 140. Okay, next piece of information. So you can work with triangles. If you have a right angle, it's always 90 degrees. Remember, what's a right angle? Perfect corner, like the corner of a piece of paper. This piece of paper, the corner is 90 degrees. Perfect, perfect, perfect. So you will see a box there. So if you see a couple lines, and somebody puts a box there, means, oh, they put a piece of paper there and made this 90. It might not be cut in the middle. Someone could put a line here and you can't just say, oh, is it exactly the same? No, maybe this is 30 and you could go, well, if it's a corner, it's a right angle, it equals 90 degrees. So I go, well, this must be 60 because 30 plus 60 would add to 90. These 2 angles that add up to 90, we have a name for them. We call them complementary angles. There's how you can write angle for short. Complementary angles are 2 angles that add up to 90 degrees. We say they complement each other. They're right for each other. Look at that couple. Aren't they so right for each other? They're always giving each other compliments. Okay, many ways you can think of this. Complementary angles, 90 degrees. Some people kind of go, hey, that kind of looks like a 90 right there. You spell complementary. Next one, a straight line is always 180. Just like if I went all the way across, bent this out straight, it says 180. So if I got a straight line and this is 40, I could go, well, this has to make 180. So how about 140? Those 2 numbers add to 180. Here's another one. 80 plus 70 plus 30, that's 180. So sometimes someone might put something like this and put things as a mystery, but they might say this is 150. You're like, well, okay, this would be 30 because that makes 180. Straight lines. Next one. These are called vertical angles. If you have 2 lines that cross each other, what's going to happen is that this angle here, whatever this angle is, doesn't it look like a reflection over here? It's right over there. Some people say, hey, it's a butterfly, But these angles, they call them vertical. They kind of look like opposite, but they're always exactly the same. And the idea is if I took a couple like pencils, if I took these pencils, these angles are the same. And even as this thing turns, these angles that are vertical are the same. They're always going to be like a reflection. Likewise, well, this angle would be the same as this angle. That'd be the same as that angle. You could even turn it. So they call these vertical angles. So somebody says this is 30, this would be 30. What if I said this was 40? Well, then you're like, this is 40. Yeah. Then what is this angle? And you could go, well, how would I know that? Well, what if I did this? Oh, I got a straight line. Straight line. Oh, and by the way, I forget. When I tell you about a straight line, we also have a name for these angles. We call these angles, well, let's actually figure this guy out. 40 and 140. But if 2 angles equal 180, because that's a straight line, we call them supplementary. Supplementary angles. So they're angles that add up to 180 degrees. Some people say, look, it's so straight, it's supplementary. Some people say, hey, what if you went like that? See, it looks like 180. Whoop, that was supplementary. So straight lines are 180. In fact, this is 140. What do all four of these add up to? However I look at this, that's 180, that's 180, these two are 180. But if you added them all up, 180 and 180, all four of these add up to 360, which makes sense because if you start somewhere and went all the way around, that would be 360. So you got to make sure they're straight. Now, be careful. If they are bent, you can't do it. If you knew this, I'm confused, right? If somebody said this was 80 degrees, oh, that's not perfectly straight lines. But I do know, maybe, I don't know what this is. What if this was 200 degrees? So I can't be 200, that's too big. But this was 150. I could figure out this now because I could say, well, all the way around is 360. And I could go, well, let's see, here's 230, subtract, this would be 130. Okay, so I could figure my stuff all the way around. Next clue, this could give some people, or next piece of information. Okay, corresponding angles. Must have parallel lines. Okay, if you've got a couple lines across, and then you put a parallel line where these lines were parallel, well then whatever happens here again. In fact, what if this was the freeway? And there was just a series of bridges along the freeway. Every one of these is exactly the same. So whatever like this angle is, it's also right here. It's also right here. It's also right here. Get a little bigger so you can see them. It's also right here. As long as these are all parallel. So these are called corresponding angles. They're all in the same spot. So somebody says, if this was 30, this is 30. With that information, could you actually fill the whole thing in? Like, if this was 30, well, this would be 30, wouldn't it? Well, then what would be right here? Oh, vertical angles. This would be 30. And then he's over here. This would be 30. I could start filling in a whole bunch of pieces. That leads to the next one. Same idea, alternate interior or exterior angles. Once again, if you have some parallel lines, if I knew this angle, let's say this angle here is 50 degrees, like that. You can color them in if you want. Well, then this angle corresponding is 50 degrees, provided these are parallel lines. It only works if they're parallel, not if it's bent. And this is 50. Well, then what do you know about this angle right here? These are the same. So a lot of people say, then these two are the same. In fact, what if I took this same drawing and only put that part? I erased this part here. You could pretend there was more here, like this, but then somebody comes by and just erases it. Yeah, they could do that. They could just like pretend that's not there. But as long as these are parallel, and this is the same as this. Some people call it the Z. This inside and this inside will be exactly the same. This is called alternate interior angles. That's how I write angles for short. So it's called the Z. So once I got a piece of information, if I've got some parallel lines and somebody tells me like this angle here is 50, then I'm going to go, okay, you're vertical, so you're 50. And you're the Z, you're 50. And you're 50. After all, these are corresponding. These are corresponding. These are vertical. These are vertical. All four of those are the same. And of course, I would know the others because I could go, well, we're a straight line. And straight lines make 180. So this is 130. And I could go over here, opposite, vertical, 130. I could go here. This is also alternate interior, alternate sides of this freeway. And they're on the interior of this drawing. 130. These out here are alternate exterior because they're on the exterior of the drawing. Okay, with that information, I could solve some problems. Okay, so if your assignment for today is to do this worksheet, there's a photo on the website. Everywhere there's like a little letter, that's what you try to find. And notice they give you some clues like, hey, these two angles are the same, aren't they? Ooh, what's that box? That's a 90-degree angle. Ooh, these two angles are the same. And now you can be a little more creative, but this has to do with triangles. These have to do with straight lines or maybe vertical lines. You might have to put some different clues together. Get a little fancier, but none of these are considered complicated. These are considered simple drawings. Here's some parallel lines. Sometimes you might turn it, make it easier. Do you see the Z? The insides of the Z. You can look at it here. The insides of the Z. And lastly, there's some stuff down here. And notice this says it's a square. If it's a square, A, B, C, D, when you name items, doesn't matter what letter you start with, but go around. A, B, to C, to D, like you're walking. You can go backwards, A, D, C, B, but you can't go A, C, B, D. But if you're naming a shape, pick a letter, go in order around it. But it's a square, so you know something about these corners. Here's another one, and this one's tricky. Don't just think these are the same. Not true. But you can figure out A and B, but I'll tell you right now, B is not 20. But use your clues. Okay, so your work is to try this. When you're done, check out the answers. And tomorrow we'll get a little bit fancier.